All right, you guys, here I just wanted to have you practice how to write your null and alternative hypotheses for one-tail upper or lower tests. And I just wanted to walk through one more example of how we do the whole process. So number one, write the null and alternative hypothesis you would use for the following one-tail upper or one-tail lower tests. So that could be left-tailed or it could be right-tailed. Okay, so A, the governor is concerned about his negatives, the percentage of state residents who express disapproval of his job performance. His political committee pays for a series of TV ads, hoping that they can keep the negatives below 30%. So right there is an identifier, below 30%. They will use follow-up polling to assess the ad's effectiveness. Okay, so I'm looking at what would be my null hypothesis and what would be the alternative. So business as usual would be that that figure is staying fixed at 30%, 0.3. So we're saying P equals 0.3. And then what is it that we are arguing has changed? So we're hoping to keep the negatives below 30%. So we're looking at P is less than 0.3. Okay, so it's telling me that it's a one-tail lower test, a left-tailed test, because we're looking at the negatives lowering from 30%. Okay, for B, only about 20% of people who try to quit smoking succeed. Sellers of a motivational tape claim that listening to recorded messages can help people quit. Okay, so here we're saying that the null hypothesis is that it stays at 0.2, right? 20% of people who are trying to quit succeed. And now we have sellers of a motivational tape. They think that listening to recorded messages can help people quit. So they're saying, well, we think that we can increase that percentage of 20%. We can help more people be successful. So the alternative here is that we are increasing that from 20%. So we're assuming that with all of these motivational methods, we're going to see an increase in the amount of people who are able to successfully quit smoking. All right, C. On to C. Here we go. 20% of cars on a certain model have needed costly transmission work after being driven between 50,000 and 100,000 miles. The manufacturer hopes that a redesign of a transmission component has solved the problem. Okay, so my null hypothesis, right, business as usual, 20%. Right, so 20% of cars need costly transmission work, right? That is our null hypothesis. Okay, and then we're hoping that the redesign of a transition component has solved that problem. So in what direction would it be helpful? Right, if we're trying to solve the problem, we want fewer models to need transmission work. So we're looking at it lowering from that 20% figure here. Okay, for D, we field test a new flavor of soft drink, planning to market it if we are sure that over 60% like the flavor. So my null hypothesis would be that it's staying fixed at 60%. And then here we want to argue in the alternative that we are increasing more than 60% like the flavor. Okay, so first step is just making sure we know how to write our hypotheses. So hopefully we did pretty good on problems A through D. All right, problem 2, just one big example. So here at least 10% of the adult population is left-handed. Suppose that a researcher speculates that artists are more likely to be left-handed than other people in the general population. The researcher surveys 150 artists and finds that 18 of them are left-handed. Is this sufficient evidence to support the researcher's claim? Use an alpha level or significance level of 0.05. Okay, So if I just sort of go through the problem first, we have 150 artists and we have 18 that are lefties. Okay, so we know that our N value is 150. That's our sample size. Our P equals 0.1. That's the parameter, right? 10% of adults are left-handed. So the complement would be 0.9. Okay, and then what is this part here telling us? That tells us that we are going to reject if our p-value, right, our probability value is less than this threshold of 0.05. Okay, so our hypotheses. So our null hypothesis, p is 0.1. So we're saying 10% of the adults are left-handed, business as usual, status quo, that is it. In the alternative, we're saying, well, among artists, we think that there may be more lefties than in the population. So we're saying, well, we think that that level should be more than 0.1. So I have my null, status quo, business as usual. What is it that I think has changed? I think that there are more lefties with this artist group than in the general population. So one-tailed, and we're saying upper tail greater than 0.1. Okay, check our criteria. So is a normal model appropriate? So is it random? Did we collect this data at random? Well, we hope so. We're going to assume that it's an SRS. Usually it says it in the fine print. Okay. Do we have independence? We're hoping that with a random sample, right, that we're not picking clusters of artists in the same community, for example, right? It should be a good distribution of all types of artists in the United States or in a certain community that we're focusing on. So we're hopeful that one outcome is not influencing another. Okay, how about our 10% condition? Are 150 artists less than 10% of all artists in the US? Yeah, we can assume so. So let me just write what I said. So 150 artists should be less than 10% of all artists in the US population. Okay, and then our success failure, do we have enough successes? Do we have enough failures? So NP greater than or equal to 10, NQ greater than or equal to 10. So we're taking the 150 multiplying by 0.1, we got 15, so check there. 150 times the 0.9, and we get 135. Good. So we have fulfilled all of our criteria. Normal model is appropriate. Push forward. Calculate. So calculate, right? We're saying, okay, P is 0.1, right? That's the 10% of adults who are left-handed. That's our parameter. Our P hat, we're saying, okay, in this artist community, 18 out of 150. So we're looking at, 18 out of 150 sampled that are left-handed, so that's going to get us a statistic of 0.12. Okay, our standard deviation, we're looking at PQ over N, so 0.1 times 0.9 over 150. Okay, so that's going to get us about 0.0245. So I have everything I need right now, right? I have my parameter, I have the statistic, I have the standard deviation. So now, let me make a normal curve, right? Where my mean is, here, P equals 0.1. And then we're looking at, well, what if we got this statistic of 0.12 or more? So that's what we're actually solving for, is what is the likelihood that we would see 12% or more left-handers among these artists. So when I type into my calculator, I'm using my normal CDF. 0.12, comma, to infinity, right? So my placeholder for infinity, I'll use 9,999. And then my mean and my standard deviation. So again, I have my lower boundary, my statistic, to infinity, because it's an upper tail test, a right-tailed test. And then here's my mean, and here's my standard deviation. So when I type all that in, I get a p-value, let me write that, p-value, probability value of 0.2072. Okay, so the likelihood, the probability of this occurring is 20.72%. So here, when I state my conclusion, I start with, here's my p-value. So with a p-value of 0.2072, we are either going to reject the null hypothesis or fail to reject the null hypothesis. So we're saying, how unusual is this? Is it unusual enough? And right now, it is not. That's not very unusual. The level that we set was at 5%, right, or 0.05. And we're seeing something that is above that, right? So not super unusual. So with this p-value, right, it's not lower than that threshold that we set up here. So we are going to fail to reject the null hypothesis. Okay, and then what does that actually mean? Well, we're saying we don't think there's enough evidence that there are more artists that are left-handed, right? We're saying we can't show that there is a shift in this instance. So we conclude there is not sufficient evidence that artists are more likely to be left-handed. Okay, so quick little recap, right? Our hypotheses, we say, are null, business as usual. What is it that we think has changed? So we know that there's 10% artists, or not artists, 10% lefties in our entire population. And we're saying that we think that there might be more than 10% that are artists that are lefties. Okay, checking our criteria for if a normal model is appropriate. We need randomization, we need independence. We need to know that, 150 artists is less than 10% of all artists in our population. And we need to make sure that we have enough successes, enough failures for our distribution to look fairly normal. And we have fulfilled all of our criteria. So now we push forward and we calculate the p-value. So to calculate it, we need to know what is our parameter, right? That's the 10% of lefties in our adult population. So this is what our mean is. That's what we're building our distribution around. What is the statistic that we came up with? We came up with 12% of lefties among the artists. How unusual is that? Well, got to figure out the standard deviation. So standard deviation, PQ over N, square root, we have 0.0245. So to find how unusual this result would be, I take it to my normal curve. So here's my mean, here's the statistic that I obtained. And we are saying, do we see that there are more lefties among artists than the general population? So we're seeing, is this an unusual result? Not really, not that unusual, right? Our p-value would be 20.72%. So if we are building our distribution around a mean of 10% lefties, right, seeing 12% or more, right, is not that unusual. We're seeing that that would occur in 20.72% of all samples using the same methodology. So now we draw our conclusion. We're saying, okay, first and foremost, this is the probability of this playing out. My p-value is 0.2072. Since that is higher than the level that we set right here, is higher than that alpha level, that significance level of 0.05, we are going to fail to reject the null hypothesis. If it had been lower than this threshold, we would have rejected it instead. So instead here, we're failing to reject it. Now, what does that mean when we fail to reject it? We're saying, it doesn't look like there is really a change. We conclude that there's not enough evidence to suggest that artists are more likely to be left-handed than the general population. All right, I hope that extra example helped. Have a wonderful rest of your day.